Hello guys, in this video we will discuss some tasks and theory to help you to prepare for the exam. So now I'll show you the video because when I recorded it, the sound just didn't record. So now I will comment what I was doing here. So first of all, we have our table about labor, total product, marginal product, and average product. And marginal product is a derivative of the total product, or we can say that marginal product is equal to a change in total product divided by change in labor. So here I'll show you how to find marginal product. Yes, so we go from the first row to the second row from 0 to 6, and we need to subtract 6 from 0, and we will receive our marginal product in the first case. So yes, from 6 to 0 will be equal to 6. The next step is to go from 6 to 14, and in this case we go from 14 minus 6 will be equal to 8. From 14 to 26, 26 minus 14 will be equal to 12, and so on. So that is how we find our marginal product. In the last row we have 60 and 61, so we go from 61 to 60, and in this case marginal product will be negative because 60 minus 61 will be minus 1. So yes, minus 1. And about average product, it is equal to total product divided by the quantity of labor. So how do we find it? So we take our total product, which is equal to, yes, we take our total product, which is equal to 6, divided by the quantity of labor, which is equal to 1, and receive 6 as average product. In the second case, we take 14 and 2, divide 14 by 2 and receive 6. So the same procedure we repeat for the other values of average product. And speaking about how can we find maximum and minimum of total product, if the derivative of the total product is 0 and the second derivative of total product is less than 0, then it will be the maximum of total product. And in the second case, when the derivative of the total product is equal to 0 and the second derivative of total product is more than 0, then it means that the total product is minimal. So yes. And here we will consider the relationship between different cost curves. You can see marginal cost, average total cost, average variable costs, and average fixed cost. So the most important thing here is to remember how the graph looks because you can derive from the graph all the needed information about what happens where marginal cost is less than average total cost and so on. So now I'll explain how we can derive this knowledge from the graph. So yes, in the first case, when the marginal cost is less than average total cost, we need to look at the part of the graph where the graph of marginal cost is below the graph of the average total cost. So yes, here are our curves, marginal cost and average total cost. And we need to see that in this part, marginal cost is below the average total cost. So yes, it is here. And what happens to average total cost in this case? We can see from the graph that it is decreasing. Speaking about the second case, where marginal cost is higher than average total cost, we need to look at the part of the graph where marginal cost is placed higher than the average total cost, and in this case it will be this part. Yes, this one. And we can see that average total cost is increasing in this case. So what happens where marginal cost is equal to average total cost? In this case, we will need to find the point of intersection of the marginal cost and average total cost. And it is not very clear from the graph, but in theory it is the minimum of average total cost. So it's the minimum. So now let's discuss what happens with marginal cost and average variable cost. So firstly, we will look on the part where marginal cost is lower than the average variable cost. So we know here is average variable cost, here's marginal cost, and this part is where marginal cost is lower than the average variable cost. And what happens to the average variable cost? We can see from the graph that it is decreasing. It is decreasing here. And the last marginal cost is higher than average variable cost. So we will look at this part of the graph. Yes, this one. In this case, average variable cost is increasing. And the last point where marginal cost is equal to average variable cost, we can see from the graph that it is an intersection between marginal cost and average variable cost, and this means that it is minimum of average variable cost. So that was about theory. And here it is exercise number 2. We have our production function about quantity is equal to square root from K and L. We are given pay for labor, pay for capital, and total cost. And we need to find optimal quantities for Q, L, and K, and it will be our optimal choice. So first of all, we need to remember some theory. It is about the relationship between marginal product of labor, marginal product of capital, pay for labor, and pay for capital. So marginal product of labor divided by marginal product of capital is equal to pay for labor divided by pay for capital. And our total cost function will be equal to pay for labor multiplied by labor plus pay for capital multiplied by capital. And if we look at our task, we can see that we are given pay for labor and pay for capital. So we know this number and this number, but we don't know pay for labor and marginal product of labor and marginal product of capital. So let's find marginal product of labor firstly. So marginal product of labor will be equal to the derivative of our total product, and it is our function in the beginning. And then we need to slightly rewrite it in more convenient form, so we will understand what's going on. So k in the power of 1/2 multiplied by labor in the power of 1/2, and when we take the derivative of the total product by labor, we consider capital fixed. Capital should be a constant in this case, and the labor is variable. So yes, capital is considered as a constant. So we will write it in the beginning. And what happens to labor, which is variable in this case? So as you remember, we have something like x in the power of 1/2, and the derivative of this is 1/2 because we take this power down, and the power of x will be 1/2 minus 1. 1/2 minus 1. And in our case, we will take the power of labor. It will be 1/2, and the labor will be in the power of minus 1/2, because 1/2 minus 1 is equal to minus 1/2. So after rewriting our marginal product of labor in more convenient form, we receive square root from k divided by 2 multiplied by square root from labor. And now let's talk about marginal product of capital. How do we find it? So it is again the derivative of total product by capital in our case. We take our capital as a variable, and labor now is constant, it is fixed. So that is why the square root from labor comes first. Then we need to take the power of k, it is 1/2. And k will be in the power of minus 1/2. So nice. Let's find, so again it is rewriting it in more convenient form. Now let's find the ratio between marginal product of labor and marginal product of capital. And we will need to take our values. So square root from k divided by 2 multiplied by square root from L, it is marginal product of labor. And we divide it by the marginal product of capital, which is in our case square root from L divided by square root from k multiplied by 2. So we receive square root from k multiplied by square root of k multiplied by 2, because we take this part divided by 2 multiplied by square root of L multiplied by square root of L. Now we can divide our fraction by 2, and finally we receive k divided by L. So our next step is to use the first system to find the solution. So we already know marginal product of labor, marginal product of capital. We know pay for labor, pay for capital. We know total cost. We know pay for labor, pay for capital. So we just need to insert our numbers which we received from our computations. So instead of marginal product of labor and marginal product of capital, we use k divided by L, and instead of the right part with the pay for labor and pay for capital, we take 2 divided by 3. And the second equation, it is about the total cost. So we know from the beginning that the total cost is equal to 90. So 90 is equal to pay for labor multiplied by labor plus pay for capital multiplied by capital. So we'll take 2 instead of pay for labor and 3 instead of pay for capital. So it will be 2L plus 3K, and you see it is just a linear system with 2 equations and 2 variables. So we just need to solve it. So let's do this. So it will be 3k yes 3k is equal to 2L, and rewriting the second equation. And now we will need to take 2L instead of 3k and put it into the second equation. So like this, and finally we'll receive that 90 is equal to 4L. L is equal to 22.5. 3 capital is equal to 45. K is equal to 15, and it is our optimal choice. So let's see how many units will be produced in this case. So we need to use our production function from the beginning. So Q is equal to square root from capital multiplied by labor. So we know our capital and labor. So we just put these numbers and compute the square root from it. and yes, it will be square root from 337.5, and it is approximately 18.4, and it will be the part of the answer. So this is it about these exercises.